So today's lecture is about spanning tree. So spanning tree, by definition, you have visited in the earlier lectures about trees. So there are n vertices, there are n-1 edges, and everything like that. So from graph we have to derive a spanning tree. So a spanning tree is a subset of a graph which has all the vertices covered with minimum possible number of edges. That's the simplest definition of a spanning tree. So if a graph is weighted and there can be multiple spanning trees among it, so the minimum spanning tree is the spanning tree where the cost is minimum among all the spanning trees. So let us see an example to understand what's the minimum spanning tree. You have in the left hand side in the orange, you can see that ABCD is a graph with where the edges are weighted. We find we select two spanning trees from it, that is ACDB, and we add their vertices. That is 4 plus 5 plus 2 is 11. And we find another spanning tree, that is CABD, and we find the edge values are 4 plus 1 plus 2, that is 7. So amongst them the minimum spanning tree is this one, that is CAB. So there are two algorithms to find them. So one is done by the edges and another done by vertices. The edges are called the Kruskal's and the vertices one is called the Prim's algorithm. So let us see about the Kruskal's algorithm. So Kruskal's algorithm builds a spanning tree by adding edges one by one into the growing spanning tree. So what it does basically, it sorts the edges by their weights and then it adds edges one by one until it forms a cycle. If it forms a cycle, the edge is rejected, and until all the vertices are connected, then it stops. It follows the greedy approach as in the iteration to find an edge which has the least weight and it adds to the growing spanning tree. So the steps are, you can see the sort the graph edges with respect to their weights. Start adding edges to the minimum spanning tree from edge with the smallest weight until the edge of the largest weight. Only add wedges which doesn't form a cycle, edges which connect only disconnected components. So we'll see an example how this works. So you see this is our graph, and you see the edges are basically 1, 2, 3, 4, 5, 6, and 7. So first we use 1 to add this 2. Then we select 2. Then we select 3. Lastly, when we are selecting 4, we see that it forms a cycle. So 4 is rejected. So we add then 5. So this one, all the vertices are connected, and this forms our minimum spanning tree. Its value is 1 plus 5 is 6, 6 plus 3 is 9, 9 plus 2 is 11. So in your exams, the questions may come like that. In a Prim's algorithm, unlike the Kruskal's algorithm, it adds vertex to the growing spanning tree. So it takes any vertex. So basically it measures two disjoint set of vertices, one containing the vertices and in the growing spanning tree, and the other that are not in the growing spanning tree, right? So it selects the cheapest vertex that are in the that is connected to the growing spanning tree and is not in the growing spanning tree. That is connected to the growing spanning tree and is not in the growing spanning tree and add it to the growing spanning tree. This can be done by the priority key. Insert the vertices, they are connected to growing spanning tree into the priority key. So check the cycles. So if they mark the nodes which have been already selected and insert only those nodes in the priority key that are not marked. That's how it works. So it doesn't add vertices which are marked. So let us see how does it work. So this is our vertex and the edges that are connected, one is 1 and 2. So it selects the cheapest one, that is 1 it selects. Then it's amongst them, it again selects basically another one, that is basically 2 it selects. So when these are two selected, so this is the cheapest vertex among them two, right? First one, then 2 is selected. Basically, this is the cheapest vertex among them. Then it selects basically connected with the 3 and 4 and 5 are there. So 3 forms a cycle. So it doesn't connect it. 3 doesn't connect it and it doesn't add any vertex also. So 4 adds a vertex and it doesn't form a cycle. So this vertex is added. So use Kruskal's algorithm to find the minimum spanning tree, and step 1 is done for you. Thank you.